Alright, so hello everyone and welcome to another video on this channel. Okay, so in this video we're going to be talking about finding the domain and range of linear and quadratic functions. So basically a function is like a machine in which you put in acceptable inputs and then you get a set of outputs. So the set of acceptable inputs that you put inside that machine, or basically your function, is called the domain of that function. And the set of outputs that it produces when you put each input inside the function is called the range. So we're going to start with the linear function. So a linear function is one of this form, ax plus b. So our first example, we're going to be looking at f of x equal to 2x plus 3. And I would like you to note that for any polynomial function, the domain of that polynomial function is always the set of real numbers. So by set of real numbers, I mean R. So it ranges from minus infinity to infinity. And also, it turns out that for the linear function, the range is also the set of real numbers. So for any linear function, you see, the domain and range of the linear function is a set of all real numbers. So basically, for this our example, the domain is going to be the set of all real numbers, and the range or you can write this as negative infinity to infinity, and this, they both mean the same thing. So let's see if you can do for the quadratic part. Alright, so the first example for the quadratic part is to find the domain and range for f of x is equal to x squared plus 2x plus 3. So remember in the previous example, I talked about the domain of polynomial functions, and I said that the domain of any polynomial function is the set of real numbers. So x squared plus 2x plus 3 is a quadratic function, and quadratic functions are also polynomials. So it is a polynomial function of degree 2. So basically the domain of this is going to be R. So now let's focus more on the range. So to find the range, we're going to be making use of this. So we're going to put our quadratic equation into its vertex form. So comparing this, our equation with this, we can see that our A is 1, our B is 2, and our C is equal to 3. So basically, x squared plus 2x plus 3 will be equal to 1 into x plus our B is 2, 2 over 2 into 1 all square minus 2 square minus 4 into 1 and 3 all divided by 4 into 1. So simplifying this is going to be x plus 1 square minus, this should be minus 2. This is equal to x plus 1 square plus 2. So we've simplified this, we've kept it in this vertex form. So now remember that the square of any real number is going to be greater than 0. So now x plus 1 square is going to be greater than or equal to 0. So if I add 2 to both sides of this inequality, it implies that x plus 1 square plus 2 is greater than or equal to 2. And remember that x plus 1 square plus 2 is the same thing as x squared plus 2x plus 3. So this is going to be greater than or equal to 2. So our function, which is x squared plus 2x plus 3, is greater than or equal to 2. which implies that our range is going to be equal to 2, infinity. So now remember that this bracket represents inclusion and this represents the opposite of inclusion. That means it doesn't include the number. When you use this closed bracket, it means that it includes the number. This represents that it doesn't include the number, so non-inclusion. So basically our answer is from 2 to infinity. So let's see if we can apply this in another question. So for the second example, we're going to be solving this question. So we're going to be finding the domain and range of this. And yeah, we agree that the domain for any polynomial function is going to be the set of real numbers. So basically, the domain for this guy is just going to be R. So we're more focused on the range because the domain is actually just very easy to find. So to find the range, we're going to put this guy, our function, minus 2x squared plus 3x plus 5. We're going to put it in its vertex form. So comparing minus 2x squared plus 3x plus 5 with ax squared plus bx plus c over here, we have that our a is minus 2, our b is 3, and our c is 5. So basically, minus 2x squared plus 3x plus 5 is going to be equal to minus 2 into x plus 3 over 2 into minus 2 all square minus 3 square minus 4 into minus 2 and into 5 all divided by 4 into minus 2. So simplifying this, we should have this. So we're going to do a little bit of inequality. So the square of any real number is going to be greater than or equal to 0. So basically I'm going to have that x minus 3 over 4 all square is going to be greater than or equal to 0. So if I multiply both sides of this inequality by minus 2, the sign is going to change. So this implies that minus 2 into x minus 3 over 4 square is going to be less than or equal to 0. Now minus 2 times 0 is 0, so that's why we have 0 here. So I'm going to add 49 over 8 to both sides of this inequality, and this implies that minus 2 into x minus 3 over 4 all square is less than or equal to, this is a plus 49 over 8, less than or equal to 49 over 8. 0 plus 49 over 8 is going to give you 49 over 8. And remember that this is our function which we kept in vertex form. So this implies that minus 2x squared plus 3x plus 5 is less than or equal to 49 over 8. So basically our range is going to be from negative infinity to 49 over 8. So that is our range. So you can see that you just need to know how to use the inequality. So it all starts from the square of any real number is going to be greater than or equal to 0. Then when you multiply it by the constant here, if it's positive, the sign remains the same. If it's negative, it changes. And then you add your constant here. And then you've already found your range. So let's see if we can generalize everything we've done here. So we have the generalization here. So for f of x equals to ax squared plus bx plus c, our domain of f is going to be the set of all real number. Or you can basically denote it as minus infinity to infinity. It both mean the same. So for our range, we have two cases. If a is greater than 0, our range is going to be minus discriminant. This represents the discriminant over 4a to infinity, and If a is less than 0, we have that our range is going to be from negative infinity to minus discriminant over 4a, where your discriminant is equal to b squared minus 4ac. So in order to find the range using this, you just need to find out your values of a, b, and c. So in our first example, we did for x squared plus 2x plus 3. Our a was equal to 1 here. Our b, which is this, b is equal to 2, and our c is equal to 3. So we are going to find out what this is. B squared minus 4ac is going to be 2 squared minus 4 into 1 and into 3, which is equal to 4 minus 12, which is equal to minus 8. So we found out that our discriminant is equal to minus 8. Our a is 1, which is greater than 0. So we're going to use this first case. So basically our range is going to be minus discriminant over 4a, which is minus 8 over 4 into our a is 1. Okay, this is going to be minus 8 divided by 4 into 1 till infinity, which is equal to 8 over 4, which is 2, so 2 to infinity. So let's see if we can use this for our second example that we did. So our second example was minus 2x squared plus 3x plus 5. So here our a is equal to minus 2, our b is equal to 3, and our c is equal to 5. So we calculate our discriminant, which is b squared minus 4ac. This is 3 squared minus 4 into minus 2 into 5. So this is going to be 9 plus 40, which is going to be 49. So since our a is minus 2, which is less than 0, we're going to be using the second case. So our range is going to be from negative infinity till this is negative 49 over 4a, which is 4 into minus 2. Simplifying, you get minus infinity till 49 over 8, because the minus here will cancel the minus here, so you just have the plus. So you can see that this actually works for finding the range of any quadratic function. So you can use it if you are in a tight spot where maybe it's just an objective exam and you just need to provide the answer quickly. Yeah, it's going to help a lot, and it looks quite easy to know offhand. So if you're in a theory exam and you actually just need to show your workings, you can use the other way. All is still fine. So thank you for watching. Help me and subscribe. Help me like, and yeah, you can help me share this video to your friends.